Alright, so this is going to be a video working on an example using integration by parts. Now, what the thought process that I want going through your head when you solve an integration by parts problem is thinking, is there any way you can just use an antiderivative rule for the expression that's given here? So is there an antiderivative rule for that? And you can quickly see that there really isn't. Next thing I would say is see if you can simplify anything, which we can't. And then the next thing I would say, try integration by substitution. Is there an instance where the derivative shows up somewhere in the same problem, being multiplied usually? In this case, it wouldn't be. So the next thing on the docket is integration by parts. Now, integration by parts uses the following formula. Okay, so using this formula, we basically are trying to solve this part right here. So the right side based on what you start on with the left side here. So this left side is basically correlated to the beginning of this problem right here. So we need to figure out what our u's and v's are, and then our du's and dv's as well. The general rule of thumb is your u, you're going to want that to be either a log. The log's not there, you're going to want to try inverse trig. So I guess I should write this down. Log inverse trig. The A is for algebraic, so if there's any algebraic terms in there that you can use. Next would be a trig, just regular trig, non-inverse, just a regular trig, and then lastly exponential. So this is just a general rule of thumb, basically for what you want your u to be. If there's a log, then set your u equal to that log. There isn't in this case. Inverse trig, there's nothing. Algebraic, there is an algebraic part to this, which is that x. So based on this late rule, the way I always think of it too is like you are late. It's kind of almost forms the word late. It's kind of easier if you go backwards on it and you solved for what the dv is. I guess you can kind of think of it that way too. Your dv, because it kind of forms the word detail if you use the d in the dv. The dv is this part right here I'm circling. But I always go off the u because that seems to be the general rule of thumb. But it doesn't matter. Either way, our u is going to be this x. So what I'm going to do is write that down over here and try to keep organized as much as possible for doing this type of problem. From there, I'm going to solve for du, which in this case would just be 1 times dx. Now the reason for that is the derivative of u with respect to x is equal to 1, and then I just multiply both sides by dx. Okay, but a lot of times I'll just start with a dx written over there because I just implied that I multiplied it over. Okay, next we need to figure out what our dv is. Okay, our dv is going to be the only thing that's left, which is this sine x dx. So we're going to say that dv is equal to sine x dx. Now you might be thinking, how do we know to find the dv? Because this right here. Okay, we found the u, but now we need to find the dv. U is x, dv has to be the other thing. So essentially this is going to be our u, and this is going to be our dv. From there we need to figure out what the v is, because the v is used in the formula here and here. So v is going to be equal to the antiderivative of what you have right here with the sine x. I'm not going to worry about the plus c for right now because it's going to come out later on in the end, so we're just going to ignore that for now. This should be negative cosine x. Now I have every single part to this equation. I have the du here, I have the u, I have the v. We're good to go. Now we can fill out that integration by parts formula. So I'm going to say this is equal to, let's say it's equal to a. It doesn't really matter, I just don't feel like rewriting it. So a is going to be equal to u, which is x, times v, which is negative cosine x. Okay, so again, I just did this part right here. Now it's going to be minus the integral of v, which is negative cosine x, times du, which is this part right here. It's just going to be dx. Okay, now you can see this is not too bad of a problem to solve afterwards because this part right here is just negative x cosine x. This part right here is just the antiderivative of negative cosine x. It's actually easier if you just did plus here, and then you end up with sine x. And I said this before, but you're going to want to add that plus c in there to find the antiderivative of this a part, this original part, not a, but this integral in black up here. And that's basically it right here. Now the next thing you're going to want to do is take the derivative of what you got and see if you get where you started. This can take a little bit sometimes, but it's still good to check. So what I'm going to do is find the derivative. So I'm going to find a prime of this really quick. And you have to use product rule on this first one. So it's going to be f prime, because the derivative of negative x is negative 1, times g, f prime g plus g prime, which is going to be negative sine x, times f, which is that negative x, plus the derivative of sine x, which is just cosine x. The derivative of c is 0, so I'll put it in there for fun. This negative cosine and positive cosine is going to cancel. The negative negative here is going to be positive, and you end up with x sine x. So you know that this right here is correct because if you did the derivative of it, you get where you started. So that's basically a worked out example of integration by parts. If you have any questions about anything in this video, let me know.